Welcome to the General Chemistry 1 class. This section is on the electronic structure of atoms, focusing on diamagnetism and paramagnetism. In this lesson, we will determine the magnetic property of the atom based on its electron configuration. Recall that electrons can be thought of as charged particles spinning around its axis. As a result, they create magnetic field. Moreover, electron configuration is a notation used to represent how electrons are distributed in different energy levels and orbitals of an atom. The electron configuration of an element gives us a hint about the magnetic properties of an element, whether it is diamagnetic or paramagnetic. Diamagnetism arises from cancellation of magnetic properties upon the interaction of two electrons with opposing magnetic spins. The cancellation occurs when an orbital is filled with two electrons that are of opposite spins. On the other hand, paramagnetism occurs when an atom or ion consists of at least one unpaired electron. As the number of unpaired electrons in a subshell increases, the magnetic field intensifies. Looking at the electron configuration, an atom or ion is diamagnetic if all the subshells are completely filled. Otherwise, it is paramagnetic. We will discuss how electrons in diamagnetic or paramagnetic elements occupy the orbitals in the next lesson. Example number 1. Identify if neon Z is equals to 10 is diamagnetic or paramagnetic. Solution. From the previous lesson, we learned that the electron configuration of neon, which has 10 electrons, is given by 1s2, 2s2, 2p6. Notice that the 1s, 2s, and 2p subshells are completely filled. Thus, neon is diamagnetic. Example number 2, identify if sulfur Z is equals to 16 is diamagnetic or paramagnetic. Solution. We answered in the previous lesson that the electron configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. The 3p subshell, which consists of 3 orbitals, is not completely filled. Thus, sulfur is paramagnetic. Example number 3. Identify if cobaltose cation Z is equals to 27 is diamagnetic or paramagnetic. Solution. The cobalt atom has the following electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s4, and 3d7. To convert cobalt to cobaltose cation, 2 electrons must be removed from the atom. Thus, the electron configuration of the cobaltose cation becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d7. Notice that the 3D subshell is not completely filled, hence, the ion is paramagnetic. Experimentally, an element can be identified as diamagnetic or paramagnetic with the use of an instrument called magnetic susceptibility balance. Here, a given amount of sample is loaded in the sample holder that is positioned near an electromagnet. As the electromagnet is switched on, the sample will be attracted or repelled by the magnet. When the sample is diamagnetic, the sample repels the magnet, making its mass appear lighter. When the sample is paramagnetic, the sample gets attracted to the magnet, making its mass appear heavier. The number of unpaired electrons can be known based on the recorded change in mass as magnetic field is applied on the sample. So, to summarize, elements can be classified based on their magnetic properties as diamagnetic or paramagnetic. Based on the electron configuration, an element is diamagnetic when all subshells are completely filled with electrons. If not, the element is paramagnetic. So these are the references or bibliography for the lesson. I hope that you have learned a lot from this video. Thank you for watching and have a good day.